All right, here we have a very interesting problem, and for some reason my computer changes things when it shouldn't. Instead of having a multiplication symbol there, it changed it into a box. So just ignore that box is there. That should be multiply. Okay, here we have that we're supposed to solve this exponential equation. The problem here is that there is a lot of stuff going on. So when you're looking at something like this, you cannot get too far ahead of yourself. You're just going to have to take one step at a time and look and see what you have and what you can go, where you can go from there. So looking at this initial problem, first things first, I see that we have a power raised to a power here. That's an exponent rule. That says when you have a power raised to a power, you're supposed to multiply those powers. So that would be the 4x times e to the x squared. Now here we can't, this is an x squared. It's not an x, well, it is an x raised to the 2 power, but this is not the same as our power to power here. This is literally an x squared equals e to the 12th. Okay, now keep thinking about your exponent rules and what we're allowed to do. When we multiply like bases, our rule says we're supposed to add the exponents. So this would be e to the 4x plus x squared equals e to the 12th. Now we have our bases the same. And our rule says that as long as our bases are the same, then we should be the exponents should be equal to each other. So that means then that 4x plus x squared has to be the same thing as 12. This is a quadratic equation that we should be able to factor and solve. Let's put everything on the same side and in the correct order. So x squared plus 4x minus 12 has to equal 0. And if I factor that, hopefully it will factor nicely. So that would be x times x. 12, we need to break up 12 to get a 4 in the middle. So that would be, 6 and 2. And to get a positive 4, we'd have to have a positive 6 and a negative 2. Then we would have to set each one of our factors equal to 0. We should be an old hat at doing this by now. So x equals negative 6 or x equals 2. We have two different answers here. Now it is always a good idea to get into the habit of checking, especially when you're working with exponentials and then later on with logarithms. You really want to get into that habit because something might work in the algebra, especially when you're dealing with quadratics, but it may not work in the original. So let's double check our negative 6 and see if it works. Here we would have e to the 4th raised to the negative 6 times e to the negative 6 squared equals e to the 12th. So e to the power to power, you would multiply, so that would be negative 24 times e to the x squared, or the negative 6 squared would be 36 equals e to the 12th. And now, multiplying like bases, you add the exponents, so that would be e to the 12th equals e to the 12th. So that checks. Our negative 6 is in fact an answer. What about the 2? We'll do the same thing. E to the 4th squared times e to the 2 squared equals e to the 12th. So here, power to power, we'd multiply. So that would be, what would that be? The 8th times e to the 2 x squared, or 2 squared, would be e to the 4th equals e to the 12th. So here again, we have like bases, so we would add the exponents. So that's e to the 12th equals e to the 12th. So our 2 checks also.